All right, we're going to graph and solve from standard form where a is 1, right? So there's a coefficient of 1 there that we don't see, and b is odd. What makes this more difficult with b being odd is that the vertex is going to be a fraction, or you can think of it as a decimal, but basically it's not a whole number, it's not an integer. So it's a non-integer vertex, which makes it a little bit more difficult. Also, g of x is a linear function, which makes it a tiny bit more difficult, but we should be comfortable now with evaluating linear functions. So from standard form, what we're interested in is b and a. It's negative b over 2a, right? That's the relationship that we discovered between the x-coordinate of the vertex and standard form. So b is negative 7, right? We got a, b, c. So we got x is negative 7 over 2 times 1, which is negative 7 over 2. All right, and I'm going to keep it in fraction form because if I'm evaluating something without a calculator, fractions are easier to deal with than decimals. And the more you can be independent from a calculator, the stronger you're going to be as a math student. All right, so negative 7 over 2. If I need to remind myself, well, this is my vertex. All right, and just to get an idea, negative 7 divided by 2 is negative 3.5. So what I'm going to do to pick my other numbers is just something around negative 3.5. So I can go down negative 4, negative 5, negative 6, and I can go up negative 3, negative 2, negative 1. All right, and I'm going to use these as my input values. I'm going to find the vertex first because it's more difficult. All right, so I'm just plugging that into x squared plus 7x plus 2. All right, so I'm going to extend the page. We're going to have some scratch work down here. Remind myself f of x is x squared plus 7x plus 2. All right, so f of negative 7 halves, so if I plug in negative 7 halves, that is negative 7 halves squared, plus I'm also plugging in negative 7 halves for the other x. So 7 times negative 7 halves plus 2. All right, to square something, what you're doing is you're multiplying it by itself. So this is essentially saying negative 7 over 2 times negative 7 over 2. And this is saying 7 over 1 times negative 7 over 2. All right, and we're going to make this 2 over 1 because we're probably going to need to change this so that everything's a fraction in just a moment. So f of negative 7 over 2 is equal to, so now I'm just multiplying straight across. Negative 7 times negative 7 is 49. 2 times 2 is 4. 7 times negative 7 is negative 49. 1 times 2 is 2. And then we still have 2 over 1. All right, in order to add fractions, we have to have like denominators. Right, so we have 4, 2, and 1. But we like them to be the same thing. So the easiest thing is to make them all become 4 because we can multiply 2 and we can multiply 1 by something to make them 4. More specifically, this middle one, we're going to have to multiply by 2 over 2, right, which is a fancy way of writing the number 1. And that's so that I get a denominator of 4, where for 1, I have to multiply by 4 over 4 to make it something over 4. All right, so we have f of negative 7 over 2 equals, this does not change, so 49 over 4, plus 2 times negative 49 is negative 98. All right, fast way to do that is 2 times 50 is 100, so it's just 2 less than 100. 2 times 2 is 4. All right, 4 times 2 is 8 over 4. Now everything's over 4. One of the things I like to do is just combine first everything that has the same sign and then combine the two that have different signs. So 49 fourths plus 8 fourths is 57 fourths. We still have minus 98 fourths. All right, and those have a difference of 41. All right, so f of negative 7 halves is equal to 41 fourths, which is 10.25. Now the 10.25 just helps us when we're plotting the point. All right, so all that work was just for the vertex. And so the vertex is 10.25. Evaluating the other points is not nearly as difficult because we're dealing with whole numbers. All right, so if we do these a little bit faster, f of -1 is equal to -1 squared plus 7 times -1 plus 2. All right, and if I'm taking the time to write these to evaluate, you should be taking the time to write these to evaluate. Don't try to put it all in your calculator. Don't try to do it all in your head. Take the time to write it out. You're less likely to make a mistake if you take your time. All right, so -1 squared, that's -1 times -1, which is +1. 7 times -1 is -7. And then we have the plus 2. Well, 1 plus 2 is 3, so 3 minus 7, we get -4. All right, and then we can do the same thing for -2. All right, I'm going to clear this ink real quick so we have more room to work. Oops. Back up. Guess I'll just erase the ones down here. All right, so we still have other points to evaluate. We still have another linear to evaluate. So we have f of -2, which is -2 squared plus 7 times -2 plus 2. -2 squared is 4, because -2 times -2 is 4. 7 times -2 is -14. We still have plus 2. 4 plus 2 is 6. And 6 take away 14 is -8. All right, do the same thing for -3. -3 times -3 is +9. 7 times -2 is, oops, I wrote a 2. I should have wrote a 3. Sorry about that. You might have caught me doing that before I caught it. So 7 times -3 is -21. Right, and plus 2. All right, and that's the benefits of writing it out. Is I saw I was getting the same number that I just got before with -14, and so I recognized that I was making a mistake. Whereas if I put that in the calculator, I might not recognize that mistake. I'm gonna get a funny number in my table, and I'm gonna get really confused. So 9 plus 2 is 11. 11 take away 21 is -10. All right, what's going to happen with the rest of the table, we should anticipate with the parabola is there's symmetry about the vertex. And since this is at -7/2, then it's going to be the same distance for these other three down here, so they should be the same. So when we evaluate -4, -5, and -6, we should get the same values. We got -4 squared plus 7 times -4 plus 2. So -4 squared is 16 minus 28 plus 2. 16 plus 2 is 18. 18 minus 28 is -10. All right, and this is going to continue to repeat. So just for the sake of time, we'll use that symmetry to our benefit. All right, so those are all our points for the parabola. I'm going to graph that first. So -7/2 is -1, 2, 3.5. I'm going down 10.25, so I'm just off the graph. Then we have -310 and -410. We have -2, 8 and -5, 8. And then we have -6, -4. So 1, 2, 3, 4. 1, 2, 3, 4. All right, and if I wanted a few more points to see how steep this would be, it might help. But I can still draw my parabola. All right. now we have to plot the linear function. So I have 3, 2, 1, 0, -1, -2, -3. I'll plug in 0. 3 times 0 minus 1 is -1. I'll plug in 1. 3 times 1 is 3, minus 1 is 2. I'll plug in 2. 3 times 2 is 6, minus 1 is 5. All right, and we're kind of used to these go by threes. So it'd be -4, -7, -10. So 0, -1, up 3 over 1, up 3 over 1. All right, and we see that it hits twice. It looks like it might hit cleanly here, maybe here, but it's hard to tell just by looking at it, but we can see it in our table. All right, I can see -3, -10 in the table. All right, and I see -1, -4 also in the table. So if I wasn't sure by how accurately I graphed it, I can see it in the table. All right, and last thing we're gonna do is solve it algebraically. All right, so we're just gonna set the two equations equal to each other and solve it. We get x squared plus 7x plus 2 equals 3x plus 1. We need to set the right side equal to 0 so that we can try and factor. Subtract 3x, subtract 1. Subtract 3x, subtract 1. So I get x squared, 7 minus 3 is 4. Wait, this was a -1, so this should be +1. All right, and 2 plus 1 is 3. And I'm trying to find two numbers that multiply to 3 and add to 4. There's only two numbers that multiply to 3. It's 1 and 3, which do add to 4. All right, to make those 0, you'd plug in a negative number. So x is -1 and -3, which is the same solutions we already had in the table. All right, that's it.